All right, there's this new graduate in quantum physics, and he's getting his PhD at Caltech. He just started, and he has a channel called Quantum Sense, and he explains how the non-commutative operators in Hilbert Space mean that when you're measuring position, that means that the momentum remains in a non-local superposition, and then vice versa. If you're measuring momentum, the position of the particle remains in a non-local superposition. And what the de Broglie-Bohm model is explaining is that you don't have to use a probability or even a wave function, because the Heisenberg transition frequencies are discrete frequencies that show a overlapping of the future and the past as this non-local superposition. And so this actually determines the trajectory of a particle due to this, what they call modular momentum in the Hilbert space from the vector algebra. So then Alan Khan, he gave his lecture in 2015 on the origin of quantum randomness, and his whole point is, if you have an intuitive understanding of the mathematics, then you realize that linear time emerges from this Hilbert space that's an infinite repetition that's never the same. So it's a 2 by 2 matrices times 2 by 2 that's non-commutative because of this imaginary the imaginary number is like this asymmetric time shift that's inherent to reality. So it's what math professor Lewis Kaufman calls the primordial time, and Alan Khan calls it primitive time. So this time, it's not the same linear time of space-time, but he says because it's not observable, therefore our knowledge of observables is always limited, and it's due to this inherent limitation that we experience linear time. And so there's no way to escape the asymmetry of time that creates entropy. So that the origin of the entropy is from this deeper non-commutative non-locality that's going on all the time before we make any observation. So my point is that in meditation, you can, by not observing with your eyes closed, you can then listen at a resonance that's super radiant and it's super luminal, and you're able to absorb the negative frequencies and time reverse signals in that non-commutative non-locality. And Alan Khan, in his lecture from 2015, he still uses the music of the piano as the example, and he says there's 3 kinds of notes. One is the integer plus the 1/4, and that would be the perfect fourth. So it'd be like a wavelength of 3/4, and then the others be the integer plus 1/2, which would be like the perfect fifth. And then the octave as the second order invariant. And so he says that these three notes are all allowed in the spectrum of the octave as a scale, but they're not as chords. When you have two notes together, some of the notes aren't allowed at the same time, which is the case for the perfect fourth and the perfect fifth. And so they're isospectral because the perfect fourth is derived from the perfect fifth. So they're both a perfect fifth, but they're non-commutative because when you switch in the second invariant of you switch the shape around, so it's like changing the matrices. And the music is also discrete because it's based on that integers that are discrete. It's the natural numbers. So this is the ancient secret of the Pythagorean philosophy as complementary opposites that was covered up by Archytas and Philolaus when they created the irrational magnitude as a symmetric geometric continuum for the Platonic philosophy that then created modern science. So that's the origin of the entropy of science, because the commutative symmetric geometry is attempting to reduce the entropy of matter, while the negentropy, the negative entropy, exists in this mathematical Hilbert space of pure information, like formless awareness that's actually resonating as infinite repetition that's non-commutative. And so this is what Lacan just calls it 2-3 infinity, because that's the simplest example of these non-commutative ratios, because that's an invariant, because you have the perfect fifth as C to F as the undertone as 2/3, but then you have 3/2 is the perfect fifth as the overtone as C to G. And then in order to get the perfect fourth, you have to double the undertone as the perfect fifth as 4/3. And that does not exist as a natural overtone of the root 1. So you have to create a different root 1. And then so it has a different zero value. And that's why it's non-commutative. So it doesn't have a geometric continuum of zero as a point. And so there's no materialistic rest frame, symmetric rest frame for space-time. And space-time instead emerges from this discrete configuration process, it normally is called configuration space, but it's actually a non-local, non-commutative, discrete resonance. And so it's actually a very simple concept if you use the music. If you understand the truth of music theory, it's simple. But everybody learns music theory from the assumption of the continuum, geometric continuum mathematics, assuming the square root of 2, which actually originally was derived from the wrong music theory, because Philolaus, he flipped his lyre around so then he could use 0 to 8 as the root tonic of the 1 for the perfect fourth. So he gets 6 to 8 is the wavelength, and then you get 8, 6 as the frequency, and then you add that 8, 6 to the original root tonic of 0 to 12. So then you have 8, 6 plus 12 eighths as the very first logarithmic equation, equaling the octave. And then Archytas came along and said, well, that's the octave is then the geometric mean squared, and therefore the tritone is the square root of 2, which is from the major second as 9/8. That's then cubed as a geometric logarithms. And this was the secret origin of the square root of 2, because you could normally in music theory you would just say that there is no square root of 2. You can't hear it, you can't. But when you can turn it into a geometric magnitude, which is what Philalethes did, then now you can construct it as an observable in mathematics using geometry. And so then Archytas used that same concept to then precisely double the cube for catapult technology, and then that was rediscovered not until the creation of modern science by Simon Stevin in the late 1500s, and then Galileo and Newton and Descartes and Leibniz and all that. So the calculus ends up going back into a discrete noncommutative vector space using matrices, and so we return back to the Pythagorean philosophy as the proper intuitive understanding. So I'll link this quantum sense video on the non-commutative secret of quantum physics, and how that requires that when you have a uncertainty principle, what's going on is that when you measure the position or the momentum, that originates from the frequency, because momentum is directly proportional to the frequency, and so it originates from time frequency uncertainty in the Fourier analysis. But because it's non-commutative, you can't use a normal Fourier analysis. So this is what Heisenberg discovered, relying on the transition frequencies being non-commutative. And then Max Born recognized that it's non-commutative, but what they do is they just use a complex conjugate. So you just take the negative imaginary number, and when you multiply that, you're able to cancel out the non-commutativity and then get a value of 1 for the probability summation. But when you're doing that, you're hiding the actual truth of this, what Pascual Jordan emphasized, which is the Jordan product as the anti-commutator, and which is also called the Baker commutator, or the Baker bracket, or something like that. Instead of, this is what Basil J. Hiley talks about. He says that the Jordan product is the anti-commutator is what gets ignored in quantum physics, and that's the secret key to the de Broglie-Bohm analysis, where you have this time reversed negative frequency signal in that Hilbert in the non-commutative, non-local process is going on all the time, this active information from the future, and it's secretly harmonizing, but we can't observe it, so we try to ignore it. But this is what Alon Khan's point is, that the concept of linear time actually originates from this deeper time where you have the future and the past overlapping. And this is also based on the gravitational mass of light having, due to the 1/2 spin of the electron, that the electron is actually made up of this secret, gravitational mass of light. And that's what de Broglie originally discovered with the pilot wave model of reality. And what happened is that the only thing taught about Louis de Broglie is that he claimed, that he said that matter can be waves. But what physics doesn't mention is that he was talking about the law of phase harmony, so that the matter as waves is guided from the future by this pilot wave. And it's just because the mathematics is non-commutative, and so he was still relying on the Planck constant, assuming it has a symmetric unit of time as a second. But in fact, the Heisenberg mathematics shows that the energy has to originate from the non-commutative frequency before time exists. So when you measure a particle, you're assuming linear time exists. But as Basil J. Hiley points out, the transition frequencies don't use time as a parameter. Because the frequencies are non-commutative with the time, so it's literally before linear time exists. But as Alon Khan points out, this doesn't mean that time is not in the background. It's just because we can't observe the non-commutative, non-local time, that doesn't mean it doesn't exist. In fact, it's precisely because we cannot observe it that it proves that it exists, and that when we make the observation, then that's the origin of entropy and the apparent randomness of radiation and other quantum phenomenon. So I'm just gonna leave it at that, and thanks.